2.5 Law Cases. The paper The Supreme Court Forecasting Project, Legal and Political Science Approaches to Predicting Supreme Court Decision-Making looked at 83 legal experts and had them predict rulings of 171 Supreme Court cases in 2002. The experts correctly predicted 59.1% of case outcomes, getting 40.9% of them wrong. When the outcome was unanimous, the experts correctly predicted which way the Supreme Court would rule 65.3% of the time. A statistical prediction rule correctly predicted case outcomes based on a limited set of coded input variables 75% correctly overall, and 74.2% of the time when the Supreme Court ruled unanimously. From the paper Insightful or Wishful: Lawyers' Ability to Predict Case Outcomes, 481 lawyers were asked before a case to state their minimum goal and what their confidence was in achieving their minimum goal, and then the authors looked at the relation between a lawyer's confidence in achieving this minimum goal and whether or not they did. The results were that what the lawyers predicted was very weakly related to the actual case outcomes, and that there was no difference in the accuracy of prediction between highly experienced and less experienced lawyers. Females were also less likely to overpredict their outcomes. In fact, below 80% confidence, females underpredicted their ability to achieve their minimum goal. In addition, it didn't seem to matter whether the lawyers were able to give a reason for their confidence. In fact, lawyers who were unable to give a reason for their level of confidence actually had slightly better outcomes than those who were able to give a reason. The main takeaway is that the relation between lawyers' predictions and case outcomes is very close to a coin flip. Simply guessing every case has a 50-50 chance would not be significantly worse than how these lawyers predicted. A lawyer may be only slightly better than a coin toss at predicting case outcomes, and perhaps not actually do any better than a layman at predicting case outcomes. However, it is not then wise to reject legal counsel and argue for yourself in a trial. Similarly, a doctor may wish to operate on your knee or your heart in a way that does not benefit you and perhaps even does minor harm. This does not mean you should have your friend Bob do surgery on you. Okay, if that's not our point, what then is our point with this? It's just to be realistic about what experts can and can't do. In terms of performing some kind of procedure, you want the medical professional to do it. But in terms of what the long-term benefits of a procedure will be, especially for a long-term ailment, the medical professionals will become more fallible. Now, the more acute the problem is, say a dislocated shoulder, the more medicine comes to resemble a hard science, and the more we should expect it to behave like a hard science. But the more long-term and ambiguous a condition is, the more we should expect medicine to behave like a soft science. And the more it behaves like a soft science, the smaller the gap between experts and laymen. For lawyers predicting a case, that is more ambiguous, subjective, and long-term. For merely arguing a case, that is a series of immediate decisions informed by training. Or for medicine, perhaps heart stents actually have no long-term benefits for patients. But that is very different from saying a layman would be just as good at performing the stent surgery as a trained surgeon. Section 3. Not Supermen. 3.1. IQ by education level. So, aside from predictive ability, another thing we can look at is the IQs of people at various credential levels. This is typically not what people care about, or why they consider someone to be an expert about something. Anecdotally, the man with the highest recorded IQ in the world, Christopher Langan, was a horse rancher from Bozeman, Montana. But it is a base we should cover. There are several estimates for IQ by educational attainment that we have been able to find. The National Longitudinal Survey of Youth tracked from 1997 onward 8,984 men and women born between 1980 and 1984, and tracked all manner of data on them from employment, income, criminality, family, and, of interest here, IQ, SAT, and education level. In 2011, the NLSY published data on credential level and how this compared to a previous score on either the ASVAB, which is essentially a military IQ test, and the SAT. In 2014, the General Social Survey, GSS, recorded scores on a verbal IQ test, highest degree level, race, and hundreds of other factors. In 2014, Ryan Falk and Sean Last cross-tabulated race, verbal IQ score, and highest degree. The white numbers compare similarly to the overall NLSY 97 results. Masters and above are collapsed into graduate degree for the GSS data. And of course, the black verbal IQ is lower than the NLSY 97 results in all categories. They also took scores from the National Adult Literacy Survey, which gave standardized tests on basic writing skills, the ability to read documents, and common real-world math skills. Here are the descriptions of the skills measured in the Adult Literacy Survey. Scores on these tests had a mean, median, and standard deviations, which means Falk and Last were able to convert them into Adult Literacy IQ scores. Note that this is not a formal IQ test, but a skills test with scores presented in the same way IQ scores are for the sake of comparison. These results are similar to the verbal IQ, ASVAB, and SAT results from the NLSY 97 and GSS, though with generally a greater disparity between credential levels. The racial breakdowns are due to the focus of Falk and Last's article being race differences in IQ when education level is held constant. There are other lists floating around the internet, typically showing much higher scores than this. However, we have not been able to find the original sources for those lists or what methods they used. But since this is an ongoing project, if you can find any additional studies, we will add them to this section. The purpose of this IQ data is simply to say that highly credentialed academics are not supermen in terms of intelligence as inferred from IQ tests. While an IQ of 120 puts one above the 90th percentile, it is not some unreachable level of intelligence for even the average person, let alone a highly motivated amateur with an IQ above this. If you have tried to read academic papers, they are filled with all manner of jargon and terms that appear incomprehensible. However, any piece of jargon can be understood by anyone. There is nothing in an academic paper that is beyond your ability to understand. Now, understanding enough of the terminology and putting in the time and effort to be able to do so may not be something you will ever do, but just know that the complexity comes from the interaction of simple elements, all of which you can understand. And either with a great deal of time reading papers to where these terms become second nature, or by putting in a great deal of effort to just read one paper, there is nothing fundamentally impenetrable about academic papers, even to someone of average or slightly below average intelligence. The consensus of scientific fields is formed by people who, on average, have IQs around 123, perhaps lower for social sciences. They are not some exalted beings, but real people, who we would say are pretty smart, but not immune to the foibles of man. 3.2. Knowledge decay. But they are not experts for their IQ, they are experts for their knowledge. Well, let's look into that. Before someone becomes a research scientist, they are first a student. There are several studies on academic and student knowledge retention. And knowledge retention, of course, varies based on how much you use it. From the paper Improving Students' Long-Term Knowledge Retention Through Personalized Review, they looked at the knowledge decay of Spanish students at the University of Colorado and they found that, over the 28-day inter-semester break, there was a major decline. The paper claims there was an 18.1%, 17.1%, and 15.7% decline in the personalized spaced, generic spaced, and massed review conditions. The paper was on review methods to improve knowledge retention. However, upon looking at the values ourselves, we are unaware of where the authors got their decline numbers from, or if they are referring to an absolute or relative decline in scores. Here is the chart presented by Lindsay et al., and here are those results tabulated, along with the absolute and relative declines for the 3 review groups. They show absolute declines of 12.4%, 12.4%, and 13%, and 17%, 18.3%, and 20% for the personalized spaced, generic spaced, and mass review groups respectively. Now, assuming the raw data itself in this study isn't suspect, in this sample we saw an approximately 18.4% relative decline in 1 month. The question is, does this decline continue logarithmically, declining 18.4% off of the previous month's level until it reaches virtually nothing? Perhaps there is some rock bottom where knowledge isn't lost. For example, 10 years after learning Spanish, perhaps you remember how to count to 10 and that por qué means why. The paper, How Fast Do Students Forget What They Learn in Consumer Behavior? A longitudinal study, spent 4 years retesting 374 students who took a consumer behavior class at an unnamed Western university. The results are displayed on the graph. Of note is that the C students were found to perform below baseline after a little less than a year out, baseline being the score achieved by a random sample of students who never took the course but were just handed the final. They scored around 64%. The important takeaway is that this decline occurred among A students as well, and was just as severe. Knowledge decay, at least within the range of these students, was not less at the higher abilities. So there is no reason to assume that if you go higher than this, once you get into the PhDs, that this trend won't continue up to that level. The knowledge decline could be even more severe, since there is more knowledge to lose, or it could be less, since perhaps they use it more, or maybe those things cancel out. From How Much Do Students Remember Over Time? Longitudinal Knowledge Retention in Traditional versus Accelerated Learning Environments, the authors looked at how 270 first-year and fourth-year epidemiology students at various Canadian universities retained knowledge in either traditional or compressed super courses. The students were in 4 categories: Year 1 course in the traditional format, Year 1 in the super course format, Year 4 course in the traditional format, Year 4 course in the super course format. All students were then tested 3 months, 6 months, and 1 year after taking the course. This and the Colorado study were focusing on how students' retention varies by course type and review type. But we aren't particularly interested in that, since we are just looking at the big picture of how much academics retain. And all academics, before they are academics, they are students. On the repeat questions, after 1 year, the scores for Year 1 and Year 4 students fell 60.9% and 70.9% respectively. On the non-repeat questions, scores only fell between 49% and 54.2%. The important point from this study is that Year 4 students in both the traditional and super course setting had slightly more knowledge decay than the Year 1 students in both the super course and traditional course settings. Now, this is just one study, and the sample size is small enough that this could just be an artifact. However, you certainly cannot say that at the higher levels there is less knowledge decay over the same amount of time. There appears to be roughly as much, with weak evidence that there is slightly more knowledge decay at higher levels. From the paper, knowledge loss of medical students on first-year basic science courses showed higher retention rates than the previous study. They showed declines of only 17.6% and 19.4% for physiology and immunology students, but 52.7% for neuroanatomy students. These knowledge retention studies have been focused on retention at 1 year or less, which is understandable, given how difficult it would be to retest people 10 years out. However, there is one study on economics students that went out much longer than these. The paper, entitled Factors Determining Student Retention of Economic Knowledge after completing the Principles of Microeconomics course, and they retested 59 economics students in 1979 who had completed the course between 1971 and 1976, so between 3 and 8 years on. The results weren't presented in an easy-to-understand table or chart, but they found that knowledge in these students decayed at roughly 18% per year, and this was a continuous logarithmic trend. So, after 1 year, you only know 82% of what you knew. At year 2, you're at 67.24%. At year 3, you're at 55.14%, and by year 8, you're at 20.44%. So, at least in this sample of economics students at that time, the knowledge decay continued logarithmically. How applicable is this to other fields today? Well, would knowledge decay faster or slower in the past? Intuitively, it seems it would decay slower in the past, since there was less information overload as there was less television and no internet. What about other disciplines? Would they decay more or less than economics? There are reasons to suspect more, because economics, whatever your opinions are of it as a serious discipline, is a highly integral discipline, which is to say economic concepts aren't isolated from each other. This is just speculation, which is confirmed by the previous data presented on other fields from more recent studies, which show higher decay rates than for these economics students. But confirmed speculation is by no means conclusive. It just means that, for now, there's no reason to think that this study from 1979 doesn't apply to people today. If anything, knowledge decay is greater in fields outside of economics, and greater today than in the past. Knowledge retention is something we really should know more about. It's quite profound how little research there is, at least that we have been able to find, given how many billions of dollars and millions of life years are pumped into college.